Survey presentation, a hybrid survey of cryptographic assurance, usable security, and real world threat practices. I looked at 5 research papers that connect math, code, and people, showing how automation, usability, and teamwork come together to make cryptography actually work in practice. Let's start with why this matters. Most cryptographic failures don't happen because the math is weak. They happen because people misuse or misconfigure systems. This survey combines 3 layers of defense: automation to prevent coding errors, usability to fit human behavior, and team practices to strengthen the process. Together, these create a complete view of real world cryptographic security. Moving on to the first paper, Cognicrypt Chain. It tackles a common problem: developers often misuse crypto APIs. This tool automatically generates secure Java code for encryption and hashing. So, instead of writing complex code manually, developers get pre-verified safe templates. It's like having a built-in security expert that ensures cryptography is implemented correctly. Next paper is SOK, Computer Aided Cryptography. This paper reviews tools like ProVerif and EasyCrypt, which use formal proofs to mathematically verify whether protocols are secure or not. They remove guesswork and offer strong assurance, but they are still too technical for everyday developers. So, while Cognicrypt Gen focuses on automation, this one focuses on formal verification, both reducing human error in different ways. The third paper, Rana, shifts from tools to real world attacks. It analyzed over 34 million login attempts across universities and found that attackers don't just brute force passwords. They act smartly using slow distributed and reused credentials. The takeaway is very clear. User habits like password reuse are often the weakest part of the system. Next is Tangible 2FA, which takes a human centered approach to authentication. Instead of applications or tokens, users picked physical objects like cards or keychains as their second factor. Surprisingly, it worked really well. People found it easy, personal, and memorable, showing that when security fits everyday behavior, it's more effective and user friendly. Now, the last and fifth paper looks at threat modeling in open source teams. Even with structured frameworks like Stride, most teams still rely on discussions, intuition, and experience. It shows that security isn't just about tools or rules, it's about collaboration and communication. Good security culture comes from people working together. Bringing it all together, Cognicrypt and SOK improve correctness and automation. Arana and Tangible 2FA highlight real user behavior. Threat modeling focuses on teamwork. Together, they show that true security equal to math plus human plus process. All three must align for cryptographic assurance to hold in the real world. Looking ahead, we need systems that auto generate secure code, offer verification tools usable by everyone, enable adaptive behavior based authentication, and build security culture into agile workflows. The future of cryptography isn't just stronger algorithms, it's security that people can actually use and trust. In short, the future of cryptography isn't just about creating stronger algorithms, it's about creating smarter, more usable, and more collaborative systems. These 5 papers together remind us that true cryptographic assurance comes when mathematics, technology, and people all work in sync. Security that is too hard to use will be ignored, and automation without understanding can still fail. Real resilience comes from designing systems that people can both trust and operate confidently. Thank you so much for listening.